Modern electrical installations contain multiple interacting systems, including solar PV, battery storage, LED lighting, data and control circuits. While each system may be compliant on its own, incorrect cable routing can introduce electromagnetic interference and cause unexpected faults.
A common example is LED lighting flicker that appears only when a solar PV system is operating. In many cases, this is not an equipment fault, but the result of AC lighting cables being routed alongside PV-DC cables. PV-DC cables operate at high voltage and carry high-frequency switching noise from the inverter. When other circuits are run parallel and in close proximity, electromagnetic coupling can induce unwanted voltage into those circuits. LED drivers are particularly sensitive to this interference, making the issue visible as flicker or instability. The UK wiring regulations require installers to consider electromagnetic compatibility. Under BS 7671, Regulation 444 covers protection against electromagnetic disturbances, and Regulation 521 requires suitable segregation of circuits. Section 7 and 12, covering photovoltaic systems, also requires PV-DC cabling to be routed to minimize interference with other electrical systems. Best practice is to avoid running PV-DC cables parallel with AC lighting, data, or control circuits. Where cables must cross, they should do so at 90 degrees, and physical separation should be maintained wherever possible. Using existing cable routes may be convenient, but it increases the risk of interference and future faults. EMI or EMC filters can be used to reduce high-frequency noise and are common in industrial applications. However, filters only reduce symptoms. They do not remove interference that is induced along a cable run. Correct routing remains the primary and preferred solution. Good installations don't rely on fixes later. They prevent problems at the design and routing stage.